Drivers behind the line.
Hi, everybody. Sorry for the late start. We had to solve a few last-minute technical issues with the audio quality, but we're here. Welcome to Behind the Lines Episode 2, Introduction to the 2015 Control System. I'm Evan Morrison. I'm here with Ty Tremblay as your GameSense hosts.
Hey,
for
guys.
those of you who haven't watched Behind the Lines show before, we run an hour-long episode with a presentation by our esteemed experts, followed by a live Q&A session. You can submit questions to us throughout the show by tweeting at FRC GameSense with hashtag FRCBTL, emailing us at btl@frcgamesense.com, or by typing !question into the Twitch stream chat.
All right. Before we hand it off to our guests, we do need to mention the views expressed by Behind the Lines and the guests are those of the individuals expressing them, and do not necessarily reflect the views of first participants. So, disclaimer over. We're really excited to have our four awesome experts here. We've got Kevin O'Connor, Greg McKaskle, Brad Miller, and Mike Copioli. Kevin, why don't you go ahead and introduce yourself?
Hi, I'm Kevin O'Connor. My title at first is FRC Robotics Engineer, so that means that the biggest project that I work on is the control system and being a technical liaison for all these other great experts we bring in.
All right,
Awesome.
And Greg?
My name is Greg McKaskle. I work for National Instruments as a chief software architect, specializing in educational products.
Awesome. Brad, go ahead. Oh no, just as Brad goes out. All right, well, Brad comes back. Let's go ahead and introduce Mike.
Hi, I'm Mike Copioli. I co-owner of Cross the Road Electronics and working with the control systems team, NI and FIRST for the 2015 control system with some CAN modules. Omar is also here. He's a software engineer. Stick your head in the camera. With I'm co-owner Cross the Road Electronics. He will also be answering questions pertaining to CAN.
Perfect. All right, Evan.
Cool. Well, Brad, looks like we still have some technical issues, so hopefully he'll be back with us shortly. But Brad Miller is a professor at WPI and works with the WPI Live, so he's kind of our software and programming languages guru. And with that, let's go ahead and get started. So I think, Kevin, you're kicking things off with an overview.
Yeah, so we wanted to start off with a quick timeline of the process that FIRST went through to select the control system. And so we started off by posting a request for proposal to the public back in the early fall of 2012. And then proposals were due by that December. We had a couple different proposals that were submitted. We made our selection just before the end of that year, before the end of 2012, and notified all the partners, including the group here that you see that was awarded the based on their proposal. And we told all you about who those partners were at Championship 2013. The actual details of the NI controller were announced that fall at NI Week. And then we went into alpha testing with 9 teams we had selected that had previously done beta of the REO system in various years. We selected a group of teams that had done really well with that and sent them the system late fall that year. And they tested it. They had the system with them all the way through the season, up through the summer. And then we jumped into the beta testing this summer with closer to production units, and that will run through December of this year. The next thing I wanted to bring up, which we've sort of already introduced some experts from these different places, but the partners with us on this control system are National Instruments, who is providing the RoboREO, We've got cross-the-road electronics providing a number of the different support boards that I'll talk through real quick when we get to the slide with the system overview. We've got WPI really helping us out on the software side, Brad and his team bringing the C++ and Java support primarily. And then Andy Mark is a distribution partner working with us on getting the system actually in your guys' hands. So if we go ahead to the next slide, there's an overview diagram of the control system and what the layout looks like. So starting over on the left-hand side, you can see on the top left, the driver station is going to be pretty much the same as what you guys are used to hardware-wise. You're going to have USB joysticks and gamepads. You're going to have your laptop computer running Windows, running the National Instruments driver station software written in LabVIEW. So that should be pretty familiar to all of you. Down below that, you can see the REO. That's sort of replacing the C-REO as the primary brains. Also includes the functionality of the digital sidecar and analog breakout modules. And then speed controllers. We've got a couple on the diagram here that are the ones you're used to. We'll also be talking tonight about some of the new options that Across the Road's excited to be collaborating with another partner on bringing to us. And then we've got the voltage regulator module. That's going to sort of take the place of that 12 5-volt converter you've got, but it's going to bring you some better functionality we'll talk about. The pneumatics control module is a new CAN-enabled module from Across the Road that's going to jump in handling your solenoids, compressor, and pneumatic functionality. And then that power distribution panel is going to bring some new functionality, replacing the blue power distribution board from the old system. So with that, I think we can go ahead and hand it over to Greg to tell you a little bit more about the REO.
So the REO is closely related to the compact REO. It's actually a derivative of an academic product called the MyREO that was announced about a year ago at an iWeek. All of these products are very similar in their architecture. They have REO, RIO in the name, and that stands for reconfigurable I/O, meaning that all the I/O inputs and outputs are connected directly to the FPGA, which is reconfigurable. That FPGA then pushes information back up to the CPU, which is running a real-time operating system. And anytime you have an NI product with REO in the name, that architecture is implied. Some differences. The cost of the REO is $435 through AnyMark. It weighs 12 ounces. The compact REO, while it has compact in the name, was actually sort of the size of a loaf of bread. The REO is actually more size of a sandwich. Actually does fit in a quart zip-top bag. It is 4 to 10 times faster, in part because it's running a dual-core ARM Cortex-A9 processor. It's also running a different operating system than the compact REO. It is actually running a real-time Linux variant called NIRT Linux. It has built-in CAN connectivity, so no more bridging over Ethernet or serial to get to CAN devices. It has it's a USB host, which means you can plug USB devices directly into the REO, for example, USB cameras. And it's also a USB device, which simplifies some of your setup and your imaging tasks. You don't have to worry about IP addresses nearly as much as with the compact REO system. And finally, on the hardware side, we have the custom electronics port is a highly customizable electronics port in the middle of the REO that's team accessible, meaning that the other half of the I/O is customizable year to year based on what type of expansion board you want to place on it. Additionally, as Kevin said, all of the breakout boards have been integrated into the REO. So they are around the outside edges. They are protected and monitored for shorts and bad things happening. This also helped cut down quite a lot on the power and data connections that teams had to deal with within the robot. This should help a lot with stability and inspection. And finally, I'll point out that we've done a lot of work, though, to keep the software libraries and the software experience highly compatible and very similar. On the next slide, there's a breakout showing the CAN, PC, PCI, I2C connections, the Ethernet connections, where everything's located on the REO. I won't go into the details here, but that's available on the NI website.
All right, thanks, Greg. I think up next is Mike talking about the power distribution.
Hi. So I'm going to talk about the power distribution panel and some of the differences between the PDB from previous seasons and the new PDB that we're part of. The new PDB has 16 channels that are connected to WPI connectors. It has 3 additional channels that are used to power the REO, the pneumatic control module, which we'll talk about in a minute, and the voltage regulator module, which is taking place of the regulators that are on board the existing PD that you may be familiar with now. Some of the new features of the PDB this year, obviously CAN. There's a CAN interface, and so the question is, what would we be exposing over CAN? And the answer is, well, current of the 16 channels that are on the WPI connectors, 16 red and black WPI. We'll just refer to them as motor channels. The other 3 are for robot controller and pneumatic control module and VRM. So the motor channels are all monitored. You can monitor CAN, you can look at battery voltage, you can look at temperature of the PD itself. It also has a logging feature where we can log events that are synced to the driver station, or correction, the match time. So for example, if you were to experience something, say a minute into your match, and you can't explain what's going on, but you want a quick snapshot of what the robot's electrical system was doing, you could download that information and look at your motor currents. Maybe your left side's drawing half of what your right side is, stuff like that. So there's a lot of additional features that we added. We also shrunk it down a little bit. It's about 30% smaller than the last year's, the previous version, 2009 version. Part of that's because we removed the voltage regulator hardware from the PD and moved it to an external module called the VRM. So that's basically it for the power distribution panel. The VRM is basically a 12 volt and 5 volt boost to buck regulator. In other words, the output of the device, it'll put out 2 different voltages. It'll put out 5, it'll put out 12 volts, regardless of the input voltage. In other words, so you can be all the way down at 4.5 volts, and your output will still be 5, and your 12 volt output will still be 12, within the limitations of the device. You can't exceed the current limit, obviously, or it's going to fault. Current limits are as follows. You have 2 channels that are 12 amps. 2 channels that are at 12 volts, 2 amps each, total 2 amps, combined amongst the 2 channels at 12 volts. And you also have a 500 milliamp, 2 channels at 500 milliamps, total combined at 12 volts. Those channels are limited to 500 milliamps to allow teams to connect custom sensors, or banner sensors, for example, light sensors, for example, things that have a higher dropout. Some of the light sensors we use tend to drop out around 10 volts. This will help with that. The 5 volt side, same thing. We have a 2 amp limit, and we have a 500 milliamp limit on the 5 volt side. The 2 amp rail is to be used for the radio, and depending on what the rules will be by first, my guess is that will only be used for the radio, but that's their decision. And if you have 5 volt devices, you can use the 500 milliamp rail. But again, that's a decision that is to be determined based on the rules for 2015. But there's a lot of things you can do with the VRM outside of powering the radio that I think would be useful.
So I think next up is, pneumatics control module.
Okay.
So, yep.
Next slide, I guess.
I think we're good to go.
Okay. So the PCM CAN device takes place at the solenoid breakout and I believe the digital sidecar. It's the pressure switch is now part of the PCM. Compressor is controlled by the PCM now. I don't need a spike anymore. It's got 8 channels. You can control up to 8 solenoid channels. So four double acting, 8 single acting. You can select between 24 and 12 volts via a jumper. There's a built-in boost regulator for 24 volt solenoids. If team chooses to use that, they have an option now. Information that's sent out over CAN includes any faults that may have occurred, your compressor current, how much current the compressor is drawing, whether the compressor is enabled, whether it's closed looping, your pressure switch status, temperature, VBAT. This also has a feature, the PCM also has a feature where if a fault occurs, for example, you short the output of the solenoids, it will blacklist that solenoid and no longer try to fire it to prevent the entire bus from being pulled down from one bad solenoid. There's a lot of other features, fault handling features. Sticky faults will let you know if a fault occurred. It's compact, it's lightweight. It eliminates the need for the spike and combines basically the features of the spike and the solenoid breakout into one device. I think I covered pretty much everything on the PCM.
See you guys.
Next slide. I guess we'll move on to the motor controllers.
Okay, go ahead.
So there are potentially 2 new motor controllers that may be available to teams for 2015. May, because it's not our decision, obviously, it's first decision. But we Cross-Throat Electronics and another company you may have heard of called VEX partnered up over the summer to develop 2 new motor controllers to try and combine the features of the 2 different designs, 3 different designs actually, and try to come up with something that is better and more powerful, more feature rich and lightweight and smaller for teams. So the Victor SP and the Talon SRX are the result. Right now, the SP beta teams they've been testing. The Talon SRX is about to be released to the beta teams for testing. They're both in production. Again, the Victor SP, it's a simple PWM smart module, or simple PWM motor controller. The Talon SRX is a CAN-enabled motor controller. With the Victor, you basically have exactly what you had with the Talon or the previous Victor. You have the linear output of the Talon, you have the high switching frequency of the Talon, you have the synchronous rectification of a Talon, you have the robustness of both designs. No fan, so all passive cooling. A completely encapsulated aluminum housing, so debris is no longer an issue. A lot of the changes, kind of obvious. We got rid of the screw terminals and went with wire. It's a trade-off. You don't have connectors, a little more work to connect it to your robot, but hey, it gives you one less failure point. Those screw terminals are kind of a pain in the butt under all that vibration and shock. But these are the 2 different designs. The CAN-enabled version has a little data connector on top where you can interface encoders, you can interface potentiometers, limit switches, brake coast jumper is no longer needed with both designs. There's a button instead. The button has a light pipe on it, illuminates when the brake is lit. And when the brake is active, it illuminates. When the brake is not active, it doesn't illuminate. For teams that like to do the dynamic control, you'll have to use the CAN version because you can no longer do that with the PWM version since we got rid of the jumper. But both units are under 100 grams. The Talon's a little bit bigger than the Victor. Both have the same output. The Talon runs on up to 24 volts nominal, and the Victor handles up to 16 nominal. So it's that's it.
Awesome. Thanks, Mike. Some exciting stuff to look forward to. Kevin, I think you're talking next about some of the wireless features of the new system.
Yeah, so this side is pretty sparse because you're going to be getting the same radio that you're used to, the DAP 1522 Rev B that you've gotten over the past 2 seasons here. And the network configuration on the wireless side is going to be pretty similar to what you're used to. When you're running it at home, you're still going to run it as an access point, connect your laptops directly to it. When you're running it on the field, it's still going to be in bridge mode. It's going to be connecting to the field network just the same way. The one major difference on the network side is this MDNS protocol that is getting thrown into the mix. And we're still working on the exact details on the field side, but the goal here is to make it so that your laptop PC gets to stay in DHCP like it is when you connect to the vast majority of networks all the time. So the idea is going to be when you're at home, that DAP 1522 will run the DHCP server, hand things out, and the MDNS is going to let you switch between the USB interface of the RoboREO, the Ethernet interface of the RoboREO, go into wireless over the D-Link. The idea is that you should always be able to find the RoboREO regardless of what its IP is using this MDNS protocol. So there'll be more details of that available, certainly in the documentation. We're not going to go too deep into the technology of how that works right now, but that's something to keep an eye out on for the new system.
Perfect. All right, and the driver station, there's some changes to that. Greg, you're up next.
Okay, the driver station is largely the same. It has the same responsibilities, but has one of the changes is that the windows are resizable, reconfigurable, so they could take better advantage of larger monitors. This is also true of the dashboards. So you bring a better PC, you get a better driver station. As Kevin was saying, it uses DHCP and MDNS to find the other elements of the field and the robot. It includes a couple other tabs. One tab is dedicated to power issues. So if you have breaker trips or other information that you want to look at post-match, it has that on one of the tabs, along with a USB device test. Lets you check out all the buttons and elements on your joystick. Everything else can be very similar, though. And the next slide is moving on into LabVIEW software. So this is based on LabVIEW 2014, which was announced just a few months ago at NI Week. So it's the latest version of LabVIEW. With the addition, so you'll have all the same palettes, largely the same as in previous years, but with the addition of a power API for getting low-level access to rail voltages, PD voltages for all of the different circuits on your robot, along with event information. Also, it's been upgraded to include USB cameras in the camera APIs. So those are useful, just as usable as Axis camera. The robotics API and simulator are still included. So this includes things like forward and inverse kinematics, path planning, steering APIs, all of that's there, along with simulated robots. Deploying code to your robot no longer needs to reboot the entire RoboREO, only the process that code will run in. So it speeds things up quite a lot for all the languages, including LabVIEW. Also, it's been there for a year or two, but there's a record and playback feature that I don't see teams use very often. They may not know about, which means if you are sending video back to your dashboard, you can record that and correlate it with all of your smart dashboard data that's also being recorded. So this includes joystick buttons, joystick positions, any other diagnostic values that are in your smart dashboard or your network table are all included and recorded in the same time sequence as that video. It also includes test mode, and I guess the last thing I'll throw in it is highly compatible with previous years. In fact, many of the beta teams are able to load up their old code and run with no changes.
Awesome. All right, I think, Brad, you're up talking about the Java and C++ features.
Okay, yeah, Ben. I think there's some really big changes this year for those text-based languages. The first one I'll talk about is that we've switched to Eclipse, which is an industry standard IDE, and in fact, it's the most recent version of Eclipse. So it's not the case of having like old software or something like that. And we'll be able to track current versions of Eclipse. So it's a really easy install. You just install Eclipse, install some plugins, and you're good to go. The other thing that's really good about this is that it's cross-platform. So we have C++ compilers that will support Macs, Windows, and Linux. And then Java naturally supports all three platforms so that you could develop on anything. I mean, of course, you still need a driver station on Windows, but you could basically use anything for your development environment. So that's like a lot of people are pretty excited about that. And all these tools are all open source. There's nothing proprietary. There's no licenses to expire. So you can just keep using this stuff, for as long as you want, and it just keeps working. On the language side, there's a whole bunch of really nice changes. For Java, we're using Java 8 SE embedded, which is a full Java 8 implementation. So it's not like Squawk, which was kind of like a Java 3 level version of Java that we were using in the past. It's full Java 8, the same as what you'd see on a desktop, and it's got all the new features like lambdas and enumerations and all that stuff. The other thing that it's got that's pretty exciting is it's got the just-in-time compiler. So programs. The hotspot compiler that's part of Java 8 will find hotspots in your program and compile them into native machine code, so they'll run much, much faster, on top of the fact that the processor is much faster. So you kind of get this like double boost in speed that's like pretty good. And there's regular Java debugging through Eclipse, the same as it would be if you were on a desktop, except that it's doing it remotely to the target system, the REO. On C++, it's the C++ 11.14 standard, so that's pretty good. Again, features like lambdas, threads, regex. So you get all the latest features for C++. It's one of the most recent versions of GCC. It's 4.9.1, which is pretty current. And again, we use the GDB server for debugging, so you get like full C++ debugging, very similar to the desktop experience. In the libraries, we've made a lot of improvements. I'll just talk about a few of them really quickly. One of them is that we believe that with the CAN support in the power distribution panel and in the REO and in the pneumatic control module, there'll be a lot of use for a lot of people are using CAN for motor controllers. We re-architected the CAN support in the libraries, and so it supports all the new CAN devices. The nice thing is that there's no threading required for your programs. There's no blocking. So you basically fire and forget. You just send messages, parameters, set points to the CAN devices, and in the background, where you don't have to worry about it, we'll keep updating the devices to make sure that they stay updated, and we'll verify the parameters that are sent by reading them back. They come back about every 20 milliseconds from the devices, and we verify them. And if for some reason they change, then we re-update them. And in fact, it will even restore parameters on a Jaguar, for instance, if it browns out. So a lot of teams have had this experience where their Jaguars would brown out, they'd reboot, and then they would lose all their parameters. Well, when that happens, we notice that, and then we send back the parameters that you set it up with before that. So as long as the REO stays up, we'll reload the Jaguars with whatever they had before. So that's pretty nice. Another thing that we added was that was in LabVIEW but didn't make it into C++ and Java was interrupts and analog triggers. So that stuff is there right now. There's edge-based interrupts, so you can go for interrupts on leading or trailing edges. You can connect analog triggers to interrupts. It's pretty nice. So it's very, very nice support for additional sensing. And then there's full library support for the MXP connector and all the things that people have discussed frequently or previously, like the internal accelerometer that's in the REO and all the other features that were talked about before. And then the last thing I want to talk about is something that's kind of new. It's a little bit experimental. It's there's an FRC simulator now, this thing called FRC Sim, which is for C++ and Java. And it's similar to what was available from LabVIEW. It's based on Gazebo, which is a simulation engine that was chosen by DARPA for the DARPA Robotics Challenge. You may have read about that or seen videos or something of the big Atlas robots, kind of going through a power plant. And so it's based on that simulation. It's what's used by research universities. And so that's kind of interesting. There's several sample robots that come familiar with it, so you can become familiar with the libraries. And there's a lot of sensors available. Now, it's Linux-based, so that means you have to have a Linux install, and we actually make that very easy to get. So we have some single command stuff that will install Linux and install the simulation and gazebo and all the other stuff that you need for trying that. And so we're looking forward to seeing that as well. And then the last thing I just want to mention is that we have lots and lots of sample programs. We didn't have that before. There were a few, but now we have very, very good coverage with sample programs with all of the sensors and actuators and other pieces of the library. So you could look at sample programs and kind of see exactly how to use pieces and get an idea. And those are available for both C++ and Java. So that's about what I wanted to say. So take it away.
Okay, so if we move on to the last slide here, I'm just going to hop in and cover a few resources that you can use for looking at some of the information that's available. The first one that's on the screen there is the beta forum. And so that is the forum where we ask the beta teams to go and keep an eye on that and respond to any questions that you might have and post links to other resources that they may be posting other places. So I believe there's a thread on there that has a link to a Facebook page, some Beta Test Central that a number of the teams have put together, and they have summarized some of their findings with the beta test there. And you may find some other team-based resources that they've posted there. And if you have any questions about the system, we've asked the beta teams to be our evangelists for the system to help get those questions answered. So if you post there and you're not getting a response, we'll give them a little kick on the beta forums over on TeamForge. Go check that out and get it answered for you. Or hop in ourselves. I monitor that forum as well if it's something that the beta teams may not be in position to answer. The second resource here is the NI RoboREO page that has a number of details about the specific I/O available on the RoboREO, things like that, speeds and pin counts and things like that. And then the last thing here is the FRC blog. So if you dig through, there are a number of posts on the FRC blog that have information about the new control system. There's one about the MXP and some preliminary rules for that. That blog also contains information about what you might be seeing in your kit or what you will be seeing in your kit for control system components. So you can definitely look through that, and there are a couple blog posts that are definite 2015 control system focused that you may want to check out.
Awesome. Thanks, Kevin. So we're going to go ahead. That wraps up our presentation. We're going to go ahead into the question and answer portion. And just a reminder to everybody, we've gotten a lot of good questions so far. If you have something that you've just thought of or haven't submitted yet, you can submit through the Twitch chat by typing !Q or !question. Or you can tweet at us at FRC GameSense with the hashtag FRCBTL, or email us btl@frcgamesense.com. We'll try and get through as many as we can, but it sounds like, first off, I want to thank all of our experts for putting together a fabulous presentation. We've got what looks like a really fantastic control system for the 2015 season with a lot of improvements over what we've had so far. So nice job. And if we have the first question ready,
we sure
then
do.
We'll go ahead. Ty?
The first question is, will we have access to the software in mid-December when the RoboREO early releases, or will it be available at kickoff? It's up, you guys get to fight it out as to who answers it.
I can take that one. We're currently trying to work out the details on that to finalize things, but my expectation is that you'll be getting it at kickoff and not when you get your RoboREO. We are going to try and get at least some of the documentation out, probably some of the wiring documentation, where we're going to try and get that out to you guys before you get the parts in your hands. We know everybody's going to be real eager, and we figure getting you the right way to wire things before you get a chance to get your hands on it may prevent any mistakes going on when people get interested and curious and try to wire some things up. But software-wise, the expectation is probably kickoff.
Cool. Thanks, Kevin. Next question, I think, is actually going back to you, Kevin, or maybe Greg can answer this. But we've got the question that is, in lieu of retention clips on the I/O pins, how should teams keep their connectors secured on the REO during competition? Is there a plan for this?
Well, the early alpha versions of the board did have retention clips. The board that's currently in beta does not. And we've actually been watching that pretty closely to see how much difference it would make. But teams have a lot of choices. In particular, we have mounting plate choices so that you can actually put your own wire retention directly beside the REO. So some people may zip tie, some people may clamp, some people may actually put something that comes over the edges of the REO to go ahead and put a little bit of side pressure directly on the pins. But since the old clips didn't really have a mating interface anyway, since they effectively just put a little more pressure on, at some point they were decided that they would go with the connectors that don't have the clips.
You may also want to check out some of the work some of the beta teams have been doing. I know 111 has posted a preliminary design of a 3D printed part that may do some cool things for cable retention and wire routing. So keep an eye on some of the work that those teams may be doing to lay some groundwork for you as well.
Perfect.
Cool.
All right, let's move on to the next question. We'll try and rip through these as fast as we possibly can. We know you guys have a ton of questions. The next question is, and it's a very, very specific question, how are the USB ports used?
So the USB device is used for imaging the controller, and additionally, NI ships drivers for Windows that will bridge Ethernet over that USB cable, meaning that all of your FTP, SFTP, WebDAV, all your GDB debugging protocols will work over that USB cable. So as a USB device, you'll often use it as a replacement for Ethernet or Wi-Fi. USB host can be used for cameras, and earlier in the beta was actually used for some radio options.
Wow, that's interesting. As a follow-up, are there any plans for directly supporting the Connect as a USB device on the REO?
Well, if you Google My REO and Connect, you'll actually see a number of grad students who have done this, and they'll tell you how and show you the results. And this is one of the cool things about having the REO and My REO share so much software and hardware, is that this is the My REO has been out there for a year and is used in a lot of senior design projects at universities. So there's a lot of good libraries, source code, and advice on how to do things like attach the Connect or other sensors.
Awesome. So our next question is for Mike with Cross the Road. Is will the Canbus controlled Talon or the newer Canbus controlled Victor motor controller definitely be ready and available for kickoff of 2015, or is this still up in the air?
Well, that's a loaded question. We expect both devices to be manufactured and ready pre-kickoff. Whether or not they will be legal is up to FIRST.
Right. That's a good time to remind everybody that even though these new motor controllers have been announced, FIRST has not ruled on the legality yet. So everybody kind of expects them to be legal, but it's not official until the rules.
Yeah, I'm not going to try and capture the exact language we used in the blog post for fear of putting my foot in my mouth. But if you go back to the blog where we highlight those motor controllers, that's still the position we're in, where it's expected that they'll probably be legal, but it depends on beta testing and final approval. So the details are in the blog.
You just use the camera with OpenCV and it worked, right?
Cool.
I'm done. If Brad's done.
All right. Here comes a great one for Brad Miller. Will there be a WPI Live interface for communicating with device serially over USB, for example, as an Arduino does?
Yeah, we expect that there's no reason they can't do that. Oh, I think I muted the wrong thing before. Yeah, we actually have, we just built CV, for instance, and plug the USB camera into the REO, the thing just came up working immediately. So where it's just a Linux system, anything you can do will just work with the REO. And so, for instance, OpenCV was just able to see the camera as an example. We're going to do the same thing with other devices, like the Connect sensor or other like that.
And of course, if you want to, I think there'll be something on Arduino. Something about the Connect on Arduino or third party. There's always IRC and SPI that's available. Protocol.
All right. Well, sorry if anyone had any trouble understanding Brad. We're working on getting actual human Brad back. Robot Brad tried to take over there for a little while. Well, our next question is going to be for Mike. And do you have any recommended connectors for the power and motor leads on the new speed controllers?
I recommend the one that you like. How's that? we prefer Anderson connectors, but not every team likes the Anderson connector. This is a Talon SRX right here. On the new wires, this is actually 10 gauge wire, but it's high strand count. So when you strip it back, it's actually the diameter of a 10 gauge. So if you try to use a 12 gauge Anderson on it, you may have some struggles, but if you use a 10 gauge, you'll be fine. You can also use bullet connectors or solder it directly, which is, I think, electrically the best option. But it's not as convenient, obviously, as when you have connectors. So. But that's what we use, Anderson's.
Cool. And I guess I'll also mention that I believe they are still either screw terminals or Wago connectors on the power distribution board, right? So if you wanted to just extend those leads with a solder splice and go directly into power distribution, you could.
Yeah, correct. The power distribution is wire to board, so there's no connector needed going from the motor controller to the PD. So you could, if you wanted to, with these short leads, wire it directly to the PD. But yeah, so that is an option.
Perfect, thanks. So the next question is on the REO. This, I think, we'll start off with Kevin. Will the teams be provided with a breakout or daughter board to allow easy access to the additional I/O ports available through the custom electronics port? And if not, will one be made available for purchase?
So there's not anything, certainly at least that's been announced yet, that teams will be provided with. There's definitely opportunities with the wide variety of ways things are distributed from the kit, including first choice, that you may see something pop up there. I actually don't even know. So when I say you may not. But in terms of purchasing one, we've already seen some partners announcing, or some companies announcing MXPs for the REO and FRC specific use. And we expect that there will be a few more probably coming down the pipe before kickoff. So definitely, if you look around, there will likely be something to meet your needs there.
Yeah, keep your eyes peeled. I know of at least one, I think, by a group called Rev Robotics that's trying to make it available for a kickoff. It's basically just a proto board that plugs into that. So I don't have any more information than that, but I know I've heard of at least one. Oh, apparently Greg has one. So there you go.
All right. Next question coming up is for, I believe, Greg, in the how much or what is supported by CAN.
Well, the libraries in WPI Live are going to directly support the motor controllers, the PD, and the PCM. I do believe it's capable of talking to other devices. We may add some support for that in WPI Live in the future.
All right. And follow-up to that is there logging of operator inputs in the dashboard?
There has been logging of operator inputs if people will turn on the record button for a couple of years. I believe it's in the Smart Dashboard for Java and C++ users as well. But it's not on by default, and you may not be able to use it with the low-end netbook laptops, especially if you're doing video.
All right, thanks very much. Brad, do we have you on audio at least?
Okay, I'm not sure. How do I sound?
You sound
Yeah.
okay. I think you might have to talk a little slow in order for people to come up, but I think
Okay.
we'll be able to soldier on.
Cool. All right. So I guess Brad, we'll direct this one at you. Are there any provisions for teams using C++ with Wind River VxWorks to use their CREOs for running development code? And Greg actually
so-
might have a little more on this too, if you want to add after Brad does.
So there's a couple of things going on. One of them is that are to kind of protect people's investments in their spree. Getting some open source library sort of compilers tool chains available that you can just run with straight Eclipse. Build unfortunately, it's kind of sort of awkwardly. So from the REO to the REO, we try to make it compatible. But because of some of the language changes and some of the other features we really want to try to take advantage of, you won't be able to run on this.
All right. Hey, Brad, we're sorry, but we're unfortunately the WPI NetOps have struck again, and we're going to have to kick it to Greg to try and answer it.
Okay, so the brief answer is that the VxWorks tools are licensed, and that license has expired. You can target the CREO with other GCC distribution tools. There's some community tools that have been made available for the last year, and I think there's a bit of additional work going on to make those easier to get your access to.
Yeah, I can add some interpretation of RoboBrad there. With the different tool chains and the much nicer, up-to-date versions of things, we're going to have you're not going to be able to take your code from your RoboREO and plug it in. Even if we have an Eclipse plugin for the CREO, you're not going to be able to just take the exact code potentially and run it. But things are mostly compatible. It shouldn't be like a monumental amount of work to switch back and forth. But don't expect, especially if you're using any of the new features, to be able to just toggle back and forth like they're the same device.
Cool. I'll take this one, I guess. So the next question is, how compatible is code developed for the 2015 control system with code for the old system? Greg, I think you talked a little bit about this during the presentation. Do you want to elaborate on that?
Sure. There are going to be some minor differences, and it's going to depend a little bit on the language. If you use modern language features for Java or C++, those will not exist when you compile for the VxWorks operating system and the interpreters or libraries that are available there. The LabVIEW experience is going to be almost identical, even supporting the simulator and things like that. So it's going to vary a little bit, but highly compatible. The beta teams have actually been pretty happy with the level of compatibility.
And with the assistance of the beta teams, we've been getting all those changes in the libraries that you may have to deal with together in a document. So you'll be able to see, if I used X in the code, it's changed. Now I need to use Y in the cases where those changes exist.
Great. That'll be a huge help. Thanks, Kevin and Greg. Next, probably our final question, because we're running up against our unfortunately hard 9 o'clock deadline. 1114's got their great seminar series coming up, and we definitely want to give you guys the time to get a bathroom break before sitting down for another hour of awesome FRC learning. So our final question, and it's probably from Mike, is can current from individual channels on the power distribution, or PDP, be used as input into the code?
The answer is yes. Well, let me make sure I understand the question. Did you hear that, Omar?
No, I didn't.
All right. So can you repeat the question?
Can current
I'm gonna have Omar take this one.
Can current from individual channels on the PDP be used as input into the code?
Oh yeah, you want me to?
I'm tagging out.
I'll take this one. Hello, everyone. So not only do we log the individual currents on the channels to be extracted later by the driver station, but they're also available through the WPI Lib API and in LabVIEW. So you can actually develop your robot application to respond in real time to changes in current, if a motor stalls, or if you design your robot to actually use the current sense, you absolutely will be able to do that.
All right. Thanks very much.
All right, so once again, I want to thank everybody, all of our guests and experts for coming and joining us. Again, we apologize to everybody that we started a little bit late. We ended on time. Hopefully we didn't cut off anybody's pressing questions. But make sure that you monitor the FRC blog and the other resources that were mentioned. The PowerPoint for this presentation and this entire episode will be available on the Behind the Lines website on US First. And our next episode will be on November 5th. And we're going to be talking about gearbox and motor selection. So we don't have a whole lot of information on that just yet, but stay tuned. That'll be our next episode. And as Ty mentioned, go ahead and head over to 1114's Symbotic Seminar. They're starting in about 15 minutes, I think. So unless anybody has anything else, thanks for coming. Thanks for everybody for watching, and we'll see you next time.
All right. Thanks to the guests, and talk to you guys later.